Kia ora everyone, welcome to my video on linear graphs. Just as a reminder, linear means straight, so if you look here on the right, we've got our grid, we've got our x-axis that's horizontal and our y-axis that's vertical, and we've got a linear graph line going right through the middle diagonally. So linear means straight. Our line here is straight. It's not curved. It's not a circle, it's not wavy like a parabola, it's straight. Just as a reminder, our basic formula for a straight line can fit into the form y equals mx plus c, where m can be any number. It could be a fraction, it could be a decimal, it could be a whole number. Same with our c. If you look here, I'd like you to note that the equation of this graph is y equals x. So when x is 0, our y is 0. So if you look at our graph, we've got x down here. Our x numbers are coming horizontally, our y numbers are vertical. When x is equal to 2, so is our y. So it's the same as saying 1 times x. So 1y is the same as 1x. Now, if we change our c value is our constants value. So if I adjust it on the left here, let's see if I can get a whole number. Whoops. Can you notice that as I'm trying to increase this, the line goes up? Got it. Okay. So when our c is equal to 1, our y-intercept is also equal to 1. As I increase it, our y-intercept, remember intercept means to cross over, so our y-intercept goes up. As I decrease the y-intercept, the c value, the y-intercept goes lower. When c is a negative number, so is the y-intercept, and it goes below the 0 on the y-intercept. Okay? So, if you're trying to make an equation from the graph, you might not know the slope yet, but your c value you can read straight off the graph by looking at the y-intercept. So for example, we haven't changed the gradient. It's going to be x plus something. It hits at 5 right here. So it intercepts at 5. So our equation, if you look down here on the bottom left, is y equals x plus 5. If I move it lower, let's see if I can hit 4. Okay, our y-intercept is 4. If you look at your graph, at positive 4 on the y-intercept, that's the vertical axis. Now, and then if you look at our equation is y equals x plus 4. And it continues on this fashion and it doesn't stop. Okay, so we could hit c is equal to negative 5. So below the 0, down here, negative 5 on the vertical axis. It intercepts at negative 5. So our equation is y equals x minus 5. Okay, let's take this back to 0. And let's look at the gradient. So remember, we've got rise over run. Our gradient is rise over 1. So it's the difference. So that's, remember, when we talk about difference, it's something minus something else. So here, we've got the difference between 2 and 0. Sorry, let's take these 2 points. Let's take the point 0, 0, right here in the center. And let's take the point. Let's see if I can make this bigger for you. Got it. Whoops. Okay, so down here on the right hand side, in the left of the right hand side, let's say, we've got 0, 0. And here we've got 0.11. So rise would be going up. So we've got 1 minus 0 would be 1. And then we've got down here, our run is going across. So that is 1 minus 0. And that is also 1. So 1 divided by 1 is 1. Anything divided by itself is going to be 1. We've got our gradient. M is our gradient. Remember, M is our sign for gradient. So if you look here on our right at the top, we've got M equals 1. Right. If I increase this, what's going to happen? Let's see if we can increase this. Okay. Now we can see at the top here it says a gradient of 2. But what does this actually mean? Now let's take it back to our basics. The gradient is the rise over the run. So if we go back to our 0 and we go, remember 2 is the same as 2 divided by 1. So we go up 2 and across 1. It's rise over run. So we go up 2 from 0 and we go across 1. And can you see that our graph crosses through this point? Let's look at the next one, shall we, from there? So we've got 2 and 1. So from the point 1, 2, remember in our coordinates we're always taking it in alphabetical order. So that means x comes before y in our coordinates, and we have to have the brackets around it as well. So if we take it from 1, 2, let's go rise. Let's see, our gradient is rise over run. And our rise is 2, so we go up 2 and we go across 1. Can you see it is the same each time we go along? So at our point 2, 4, let's do it again. Up 2, across 1. So this is how we can draw a graph from the gradient. What if we're going backwards though? And we're trying to find the equation from the graph. Okay, so let's see. Can I see this? Sorry about that. If I change the gradient over here, try not to look at that over there. Actually, I can hide it like this. Right. Remember, our gradient is rise over run. So how many times does it go up before it crosses? Remember, it's got to be where it intersects with one of these crosses so we can tell for sure. So it starts at 0, 0, and it goes up to 1, 5. So, with rise over run, our rise is 1, 2, 3, 4, 5 before it gets to here. And so the number on top is going to be 5. And we only go across 1 to get here. So it's 5 over 1. 5 divided by 1 is 5, so our gradient is 5. So our equation is going to be y equals 5x. Because our y-intercept is 0. You can say y equals 5x plus 0, but you don't really need that 0 there. Okay, now let's have a look and see. Bottom left-hand side, sure enough, y equals 5x. Likewise, like I said with doing the differences, if you're given a set of coordinates and you don't have this graph, you can still work it out by looking at the difference between the y values and the x values. Here we've got the point 0, 0, and here we've got the point 1, 5. Okay, so you're going to... So if you notice, we read left to right. So we're looking at our points left to right. Okay, so our graph has gone up, left to right, so we know we should end up with a positive number. If you end up with a negative number, then you know that something's not quite right. So our first y point is 0, our second y point is 5. So 5 minus 0 is 5, and that is what goes on top of our fraction. Underneath, we're going to have 1 minus 0. Remember, the points are 0, 5. So our first x value is 0, our first y value is 5. Our second coordinate is 1, 5. Oh my, I think I need to rephrase that. So our first coordinate is 0, 0. Our first x value is 0, our first y value is 0. Our second coordinate is 1, 5. So our second x value is 1 and our second y value is 5. So the second y value minus the first y value is 5 minus 0, which is equal to 5, so 5 goes on top. Our second x value is 1, minus our first x value of 0 is 1, so that goes on the bottom. So we've got 5 divided by 1 is 5. Okay, so let me just show you a graphical representation of this as we change both values. So here I'm just changing the gradient, and you can have a negative gradient. Okay. Can you see that? Negative gradient makes it go down as we look left to right. And as we look left to right, now our gradient is positive. Right, what if our gradient hits 0? What does this mean? It means we're going to have a flat line. So if I change the intercept, can you see that? All this means that y is just a simple number. For example, if y is equal to 1, it will always go through 1, no matter where on the graph it is for y. So when x is 1, y is 1. When x is 2, y is still 1, because our equation is y equals 1. Likewise, if we took it up to go to 2, or we could even do 2.5, y will always be 2.5. If, however, we've got a vertical line, then we would say it's undefined, and then it would become x equals a number. Okay, so x equals a number will give us a vertical line, which I can't quite do right now, but I can still show you in class. Okay, let's see if I can do this. X equals 2. Oh, yes, I can do it. Okay, so if you see this vertical line here, this is our x equals 2. Okay, and that can be shifted, so I can easily change this. X equals 1.5. Did you see that just shift here on the left? Let's see if I can shift that up a bit further, so I can see it when I'm putting in the numbers. Okay, so if we're looking here, I'm going to, on the right, I'm going to change the number. If I say it's equal to 0.5, can you see it shift all the way to 0.5 or halfway? So it's the same kind of thing, it just moves. Okay. So if I take that line off. So going back to our now horizontal line with no gradient, as I change the C value, it goes up and down. Okay, but each time it's still got an X, it's still got the Y equals something times X, which is our gradient. As our gradient changes, that number in front of the X changes. As our Y-intercept changes, our C value changes. C stands for constant. C for constant. Okay? So a constant value is generally our Y-intercept. That's it for the first video. Thanks for watching.